Hello, everybody. Today we're going to be talking about what science is and specifically what physical science is. You should have watched already the video of the Keeling curve, and that was a good example of physical science. The link to that video is right here if you just want to watch the video on YouTube, although it doesn't have the embedded questions that were in it on the actual link in Google Classroom. So before we really move on from this slide, I want you to think for a minute, like, what is your definition of science? How would you define science? I don't want you to look it up in the textbook. I don't want you to look it up in the internet. I just want to know, what is your definition of science? And then list a few examples. Here's another video, and I'm not going to play it in the Google slide because when I tried that earlier, it kind of slowed things down. But we'll watch that one a little bit later. It actually shows how scientists measure the carbon dioxide, and the guy that you're seeing on the screen there is the son of the person that was in the first video. All right, so science stems from curiosity. It begins with questions that are driven by curiosity and it ends with discovery. The pandemic is a perfect example. I don't want to talk a lot about the pandemic because you're probably tired of hearing about the pandemic, but it's a great example. And since this is science class, we might as well discuss it a little bit. So people were showing up in the hospitals, doctor's offices, the emergency rooms with a strange respiratory illness. And so the question is, what is this illness? What is causing this illness? And it ended with the discovery, of course, of COVID-19. In the video of the Keeling curve, the curiosity, the question was, how much carbon dioxide is in the atmosphere? And the discovery, there were actually two things. One, that there is a seasonal pattern, a seasonal fluctuation in the amount of carbon dioxide in the seasons, but also that the amount of carbon dioxide in the atmosphere has been rising over time. Science is a system of knowledge and the methods that you use to find that knowledge. It's always changing. We're always learning new information. And because of that, science is always evolving. Scientific experiments provide different types of data. In the video of the Keeling curve, you saw that it started out in, I think, the 1950s with a carbon dioxide level of about 300 parts per million, which meant if you have a million parts, 300 of them would have been carbon dioxide. And then in 2014, they were up to 400 parts per million. That is quantitative data. It's numerical data. And a lot of times in physical science, we are taking quantitative data. Qualitative data would be non-numerical data. It's observations like the color of something, the taste of something, anything that you would record that would not be numerical would be qualitative data. And then from this data, of course, an unbiased conclusion is drawn. And that part is very important. That's why scientists need a method, the scientific method, so that other scientists can replicate their experiment, confirm their data, and also hypotheses need to be tested different ways. And all of this helps to ensure that scientists are forming unbiased conclusions. Science and technology. We tend to think of technology as just being computers and smartphones, but technology is really the use of knowledge to solve practical problems. It can be something as simple as Velcro. The mask that people wear, that could also be considered technology. They talk about the N95 masks. You'll see people with masks with the little vents that help them breathe better. There's the masks that are supposed to help keep you cool. And so there's a lot of technology in our daily life that isn't just computers and smartphones. So science is basically the knowledge base we use to solve those practical problems, and the technology is the product of that. So this questionnaire here is, how do you see science and technology as related? And give an example. So just try to think of an example of technology and the science behind it. So for example, the N95 masks. That would be the technology. The science behind it has to do with the size of the particles that the masks need to filter out. As science and technology are interdependent, advances in one lead to advances in the other. And so as we learn more, as our knowledge base, our science improves, technology tends to improve. That leads to advances in technology. And then as our technology improves, that leads to more advances in science. All right, we're going to get to branches of science today. Science can be divided into two general categories. We have natural science and social science. So natural science is going to include biology or life science, as they sometimes call it. That's what you probably had, I think, in 7th grade. Then there's physical science, which you probably had, I think, in 6th grade. And that's what you're in now. It includes chemistry and physics. And then there's earth space science, which is what you would have had in 8th grade. So even though it's broken up, science is broken up into these two categories, natural science and social science, we're going to be spending our time in natural science. All right, so physical science is basically physics and chemistry. And so for this year, we're going to spend one semester in talking about chemistry related topics, and then the second semester will be physics. I want you to take a second to look on page 4 in your textbook and read the little section about a physicist and then a chemist and see what it is that they do. Give me an example. What does a physicist study? And then what does a chemist study? All right, the second branch of natural science is life science or biology. And we're going to do the same thing here. I want you to look in your textbook and answer the question, what does a biologist study? There's lots of examples. You're not limited to the examples in the textbook. And then earth and space science. This could be geology or astronomy. And so take a second to look in your book again. What does a geologist study? And then what does an astronomer study? All right, here are some big ideas in physical science. So these are some of the topics you might cover in a physical science class. Space and time, matter and change. Matter is anything that has mass and volume, so anything that has mass and takes up space. Matter is made up of tiny particles called atoms. So given that description, I want you to come up with an example or two of matter. Another topic in physical science would be forces in motion, and we'll spend a lot of time talking about forces in motion second semester. A force is generally defined as just a push or a pull. Then they are going to cause objects to change their motion, which we call acceleration. We will talk about energy in both semesters, whether we're talking about chemistry or physics. You need to talk about energy because any change would require energy. Objects have energy when they change their surroundings. Energy can be transferred from one object to another, but it cannot, and it can change form, sorry. And then the last part, it cannot be destroyed or created. Those last 2 points, B and C, are basically summing up the law of conservation of energy. Energy can be transferred from one object to another, and it can change form, but it cannot be created or destroyed. That is the law of conservation of energy. Science in your perspective. Science is always changing. I think that we are seeing that a lot right now. We have learned so much about COVID-19 since March, and it seems like new information is coming out all the time. So that's a great example of how science is always changing as we learn new information, as there are new discoveries, and as technology improves. So the question here, or not really the question, but you're supposed to think of a time when a discovery or information caused what we know to change. And I think that COVID-19 is a great example of that. If you have other examples, I would love to hear about them, but I think that we've been living that since March. So I feel like this is something we are very familiar with right now. All right, so that is the end of the notes for section 1 in chapter 1. So we're going to stop there today. Make sure you answer the questions that were embedded in the PowerPoint so that you get credit for watching the video.